Howdy and welcome back. So we'll continue today's lesson with a brief discussion on pointers. So pointer review. A pointer is going to be an object whose value is going to store an address to an object of its base type. If you recall from our introduction to the free store lesson, we said that essentially there's these different regions of memory. We have the code static region, we have the stack, and then we have the free store. We said that we can request that objects are all located on the free store with the new operator. We said that writing new int would return the address to an integer object whose memory was allocated on the free store. If we want to interact with that newly allocated object, we have to preserve its address somewhere. And the natural object who can store an address is going to be a pointer. So almost in pretty much all instances where we see the new operator, we're going to see its result, the address of the object that has been allocated for, will be stored in a pointer. And to look at how this kind of is viewed, we can pull up one of our memory diagrams. And we can essentially see here that that pointer is a named object, so it will reside on the stack, and the object to which it points is going to reside on the free store. So we have pint. It is a pointer to some sort of integer object on the free store. Since we didn't specify an initializer for this newly allocated dynamic object, its initial state is going to be unknown. But if we go ahead and look at the diagram here with these ASCII boxes, recall that all objects are going to have an address. We can see here that the newly allocated dynamic object's address is that long value in hexadecimal. We can see that we stored that address in pint, and that a pointer is an object in its own right, so it also has an address. And after executing this line of code, we can see here that we've made an association with pint pointing to that newly allocated integer object residing on the free store. And the same's happening if we're looking to allocate memory for a double on a free store. We can see here we just request from the free store manager the allocation of a double object, so new double, that will return an address to the newly allocated object. And again, because we didn't specify a starting value, its initial value is going to be undefined. And we store that address within our pointer, which again is an object in its own right. So it too would be addressable. Now let's get into some fun. So we could have a pointer to some sort of object. And we'll see that this is going to be the case in the way that we're going to introduce two-dimensional arrays on the free store. So what is P? Well, P is going to be a pointer to an integer object. So P is going to point to a pointer to an int. And just drawing this out here. Okay, so it might be easier to kind of break this up. And we're going to see here that in this particular example, because it's going to hopefully better mirror what we're looking to do with arrays, let's split it up across multiple lines. So we can see here that P is going to be a pointer to another pointer. So P points to this pointer, which resides on the free store. So let's go ahead and draw this out in our memory diagram. P is a named object, so it will reside on the stack. The object to which it points to is going to reside on the free store. So we have P is a pointer to a pointer on the free store. Now, if we dereference P, grab a different color. If we dereference P, we're going to get this object back. And what we can do is, because P is a pointer, or sorry, in this case, P dereferenced is a pointer to an integer object, we can go ahead and say that P is going to point to some sort of new integer object also on the free store, say an integer object with the initial value of 7. So that is what this line is creating here. And we're hooking that object up with the pointer pointed to by P. So if you can look at this, we can see there's, I guess, you can look at this example here, which might better communicate this. We started out with declaring P, which is a pointer to a pointer. Its value is going to be the address of the pointer allocated on the free store. So if we look here at that, just that relationship, we can see that, sorry, trying to get unique colors here. The address of that pointer object is stored in P. Now, when we perform the additional allocation on the free store, we can see here that we get, I think this is the same color, we get this object, 7. And notice that it has an address, and its address gets stored in that pointer on the free store. So, at this point, you might be going, okay, this, looks a little involved. How does this relate to two-dimensional arrays? Well, that is going to be our next discussion.